quick sort. Quick sort is also a divide and conquer technique. It is just like a merge sort. But in quick sort, all the major work is done while dividing the array into subarrays. While in case of merge sort, all the real work happens during merging the subarray. In case of quick sort, the combined step absolutely done, it does nothing. It is also called partition exchange sort. This algorithm divides the list into three main parts. The first one is elements less than the pivot element, pivot element at the central element, elements greater than the pivot element. So here pivot element can be any element from the array. It can be the first element, the last element, or any random element. So it all depends upon the requirement. So let us see the quick sort algorithm. So step 1, start. Step 2 is initialize the identifiers like array with size 20, pivot element, I, j, n, and elements to store temporary elements and temporary variable. Step 3 is to read the n value and read the elements in the array. Step 4, pick an element from the array. The element is called as pivot element. Step 5 is divide the unsorted array of elements into two arrays with values less than the pivot come in the first subarray, while all the elements with the values greater than the pivot element comes in the second subarray. That is, the two subarrays are being divided according to the pivot element. This step is also called as partition operation. Step 6. Recursively repeat the step 4 until the subarrays are sorted to the subarrays of the elements with smaller values separately and to the subarray of elements with greater values into the another array. So there are two subarrays like smaller elements to the pivot, one at one end and greater values to the pivot on the one end. So by doing this process, you will be getting the elements in the sorted position. The last step is stop. Now let us see the elements. Let us see one example related to the quick sort. So the elements are 51, 95, 66, 72, 42, 38, 39, 41, 15. So all these elements are in the unsorted order. Now first let us pick one pivot value. The pivot value is 51. Compare this pivot value, that is the second element 95 with the pivot value. If 95 is greater than pivot value and the element 15 is less than pivot value, so check for the pivot value for both ends, that is 95 and 15. If 95 is greater than pivot value and 15 is less than pivot value, swap the elements. Now after swapping, the elements are 51, 15, 66, 72, 42, 38, 39, 41, 95. Now compare the elements 66 and 41. So 66 is greater than pivot value, condition is true, and 41 is less than pivot value, condition is true. So swap the elements. Now the elements after swapping are 51, 15, 41, 72, 42, 38, 39, 66 and 95. Now let us compare 72 and 39. 72 is greater than pivot value, condition is true, and 39 is less than pivot value, condition is true. So we can swap the elements. So after swapping, the elements are 51, 15, 41, 39, 42, 38, 72, 66, 95. Now let us compare 42 is less than pivot. 38 is less than pivot element. Now we need to stop the process. Now let us take 38 less than pivot value and 72 is greater than pivot value. So find the split point, swap 38 and 51. Now we need to find the split point and we need to swap 38 and 51. So after splitting, the elements in the given array are, that is in the sub array, 38, 15, 41, 39, 42. So these element in the fifth position we have 51 and the two elements are the sub arrays. That is 72, 66, 95 is one of the sub array. Now 38, 15, 41, 39, 42, 51, 72, 66, 95. Now let us again process the same steps for quicksort recursively. Then we will be getting the sub arrays. So while in the split process itself, we will be getting the final sorted array. So this is how the mechanism of quicksort recursively works.